Um, my name is Andrew, and if you're just tuning in right now, this is a channel devoted to the GRE. You can check out all of my classes and all the information about my classes at my website. My name is Andrew, every time. And if you're just tuning in right now, there we go. Every time I do that, I'll make that kind of a clean intro again. Hello and welcome to this channel, the GRE channel. My name is Andrew. If you watch this channel, you know that I do GRE problems. I also run GRE courses and classes. So if you are looking for a GRE class, you can find information about that at my website, testprepstudios.com. Currently, I have a class running, and I like to do these GRE office hours from time to time where my students can join live and ask any questions that they are running into. So we'll hop right into this. I'm gonna download the PDF that Sarah sent me here and share it. Um, and again, Samantha, if you have any questions, feel free to just send those by email, and I'll make sure we get them in the rotation. So let's hop in. We have this question with concert tickets. Clearly a percent question. Out of curiosity, Sarah, what's the source of this one? Where did you find this question? Says it came from the Manhattan book. Okay, cool. Um, so Helen paid $252 for a conference ticket. If she had purchased the ticket one day later, she would have paid $306. How many days in advance did she purchase the ticket? Well, clearly we're talking about one of these cutoffs, right? Because and I'll go I don't know, to I guess these are all cutoffs. Well, if like for instance C, right? If I had purchased the ticket one day later, it would have been 58 days in advance and there would have been no change, right, from before. So I'm at some sort of cutoff. So either it means it's 530 uh, or 60. I not 89 either, because if it was one day later, it would be 88 days in advance, and that's no change. So right then and there, I can get rid of two answer options. Well, let's consider these one by one. So if I was at $60, right here, sorry, if I was at $60, or sorry, 60 days in advance, and I had a 40% discount, we can kind of work backwards. The price for the ticket is $252. Let's pretend that I was 60 days in advance. If this was discounted by 40%, where would I have started from? And this is where we have to do our percents. So, Sarah, how do I do a 40% discount from something? What's the operation that I need to perform to discount something by 40%?
I think that we would multiply the number by 0.4
Well,
and
if
subtract that
I,
from the number itself.
great. Great. So we could say 0.4x and then subtract that from x. The other kind of shortcut we can take is if I take 40% away from something, I'm left with 60% of it,
Yes,
right? So
correct.
I could say 0.6x equals 252.
Hmm.
Now, let's solve for x here. We'll do 252 divided by 0.6. And so that gets me $420. So we're saying the price of the ticket would then be $420. Well, it's saying if I had purchased the ticket one day later, so if I went from 60 to 59, then it would be a 30% discount. Well, what's a 30% discount from 420? That would be 294, right? So if I go 30% down, then what I'm saying is 420 minus 30% of 420 or 70% of 420 is 294. This is not the number I'm looking for. I'm looking for 306. So that one is out as well, right?
Yes.
Well, let's go to this one. And I realize it's a pretty labor intensive problem. We can keep this, right? Because this is kind of my starting point. X is like the initial value of the ticket, the full price of the ticket. Let's say that I'm at 30 days in advance. Well, the discount for 30 days in advance is 30%. So what I could say is 70% of X equals 252. The 252 divided by 0.7 gets me 360. So if the ticket was $360 and then a day goes by and now I only get a 15% discount, then minus 15%, then I'm at 306, which is what I want. I won't
Got
lie.
it.
This problem is very labor intensive, so much so. And the reason why I asked where it was from was like it doesn't quite look like an official question. As in, the test probably would not make you do this much computation. So, like, percents are important. It's important to understand kind of how percents work. But uh, not to this extent, I would say. Any questions about that, Zara?
That's good news
Mm.
because I really struggled with this problem.
Yeah.
But yeah, it was one of the last questions in Manhattan, 5 pounds supplemental homework. So that's where
Got
it came from. Thank you.
it. Okay.
I think actually majority of the questions I sent are going to be from that source.
That's totally okay. I just want to highlight which ones are official and which ones aren't.
Yes,
Yeah.
appreciate that. Thanks.
Okay, great. So still waiting on Vivian to join here. Make sure that no one's in the waiting room. Um, and Camilla and I see you in there again. As I mentioned, priority goes to students who are enrolled in the course at the moment. So we'll work through Sarah's. We'll work through anyone else who's in the course here, and then we can get to any questions that you have, Camilla. Um, this is a good one to talk about. Um, A times B is greater than 0. B times C is less than 0. Sarah, let's start with this first statement. If I tell you that when I multiply two numbers together, they're positive, greater than 0, what do you know about the two numbers?
Well, they cannot be zero because if they are zero, they would zero out. So,
Right.
well,
Equal.
yes, for the top equation at least.
Mhm.
Well, no, for both. For both.
Well, let's not look at the second one quite yet. Just for
Okay.
the if I tell you that one number times another number is a positive number, what
Mhm.
can you tell me about those numbers?
The numbers are both positive. One cannot be negative.
Or so they're either both positive or
Oh, or both negative.
both negative. They're the same sign, right? So at this
Mhm.
point, A and B are either both positive or both negative.
Yes.
Let's go from this inequality on the top to this inequality right here.
Mhm.
What is consistent from the first inequality to the second? What appears in both inequalities?
B
B
and zero.
and 0, yes. But most importantly, B.
Yes.
Now, let's think of this as a story. I went from the first one to the second one, and I changed A to C, and what happened?
Suddenly it's smaller than zero.
It became negative, right?
Right.
So what that means is that A and B were the same sign. And then I switched A. Well, I don't know what's going on with balloons there. I switched A,
Mhm.
the thing became negative.
Hmm.
So what can you say about A and C? Are they the same sign or different signs?
They must be different.
They're different signs. And if they're different signs, positive, negative, negative, positive, is that greater than or less than zero?
Less than zero.
That's it,
Hmm.
right?
That was very helpful.
One sort of little mental thing that I like to do is whenever I see greater than or less than zero, I immediately translate that to positive, negative,
Mm.
right? It's a little more, to me, like a little more natural to feel that way, to think that way.
Yes. Yeah, it helps put it into perspective more.
Yeah. Okay. Okay. So, um, let's do the next one here. If zero is less than A is less than 1 over B is less than 1, then which of the following must be true? I'll come to kind of one of my favorite little hobby horses. This phrasing, must be, right? That is basically telling you immediately find a case where it's not. And if you can find a case where it's not, it's out. Right? So let's actually just test some numbers here. Sarah, can you give me a value of A that fits the constraints of this problem?
Okay. Let's see here. Can I assume that A is less than 1? Is that accurate?
Oh, absolutely. Yeah. Right.
Okay.
These are all,
So
yeah.
it's in between 0 is less than A. So it's negative. Let's call it -1.
Oh, well, A is greater than zero, right?
Oh, I see. So let's call it point 0.5.
Love it. So A is going to be 0.5. Now, this might take a little bit of trial and error, but can you come up with a number for B so that 1 over B lands, and we'll draw this out on a number line. Here's 0. A, we're calling 0.5. 1 is up here. Well, I guess technically, if you want to be, 1 is right here. Can you come up with a number? Well, let's start with this. Can you come up with a number between 0.5 and 1?
Sorry. How about 0.05? Is that
0.05 is
smaller?
smaller than 0.5. So a number between 0.5 and 1.
So 0.75.
Sure, let's say 0.75. So this number is 0.75, but we want 1 over b to
Right.
equal
So
0.75.
hmm,
So let's do a little bit of algebra there. Can you get b by itself?
multiply b by both sides. We get 1 is equal to 0.75b. Divide both sides by 0.75. 1 over 0.75 is, well, that's a decimal again. Um, how would the decimal is 1.33 when we put,
Right? So we're
mhm,
going to say this is b is equal to 1.333.
okay.
So 1 over 1.333 is right here.
Mhm.
So far, so good.
Yes.
Well, now let's just plug these numbers in, right? Um, what's a squared?
Probably 1.
Use your calculator for this. What's point
Point
0.5?
two five.
0.25. What's well, A is 0.5. So far so
Mm-hmm.
good. What's 1.333? That's that, right?
Mm-hmm.
And 1.333 squared,
1.77.
1.77. So this works.
Mm-hmm.
Now we want to make sure that like the other ones don't, but if I'm really stuck for time, I might go for this one because I
Right,
just tested these and they all worked, right?
right.
Whereas this one,
Okay.
immediately I plug in what I tested 1.333 and oh my gosh, I'm sorry. I'm looking at the signs backwards here. In fact, this
Mm,
doesn't because this is saying
I
this is
see.
the biggest one.
Okay.
This is out
Got
because
it.
it's 0.25 is greater than 0.5. So sorry. I was looking at the signs backwards.
Gotcha.
So let's try
All
this.
good.
1.333.
Okay, so that would be is greater than point 0.5.
That's okay for now.
And a squared is 0.25,
Mhm.
and b squared is 1.77,
So that's out, right?
which is not
Okay. How about this?
1.77 is greater than point 0.5,
Mhm.
which is also greater than 0.25,
Yep.
which is greater than 1.33. No, that's inaccurate. B squared 1.33 is greater than 0.25. Yes, which is greater than, uh, oh, sorry, 1.77 is greater than 0.25, which is greater than 1.33. Nope. So that leaves us with E.
Now,
Okay.
zooming back out of this, we might be able
Mhm.
to see now that we've done it, like, okay, well, this is going to be a decimal number. And if I square a decimal number, it's going to get smaller, right? If I square zero
Mhm.
point 0.5, it's going to get smaller. It's going to be 0.25.
Mhm.
So right then and there, I can say, and I'll just rewind a little bit. I can say that a squared has to be less than a. So any answer option where a squared is greater than a, that's out, right?
Mhm.
This
Mhm.
one, yeah. And then this takes a little more kind of work, but because it's one over that, that's going to have to be a number greater than one. B is a number greater than one. And if I square that, it's going to get bigger. So I need B squared to be bigger than B. So that's out, that's in, and that's in. And then I just have to kind of test from there.
Right. Okay. Thank
Of
you.
course. All right, V, welcome. I'll run over to you here. And V is asking, would this be a realistic question? I would say this one, yes. Yeah. This one's fair game. Even though it is from, I can tell it's from Manhattan. Um, yep. The last one, not so much. I don't know if you saw that last one on the stream, V, but I was saying the last one is probably not as good. And Camilla asked a great question here. Do I recommend working with decimals better than fractions? And I'm going to say that's kind of up to you. It's a matter of personal preference. And I'll say my personal preference, not at all pushing this on anyone, is to use decimals because they're exact and you can use the calculator for them, right? It's very easy to use decimals on the calculator. But you could, and I won't go all the way back through it, but you could absolutely, Camilla, call this 1/2 and then call this, what would that have to be? B equals 4/3, for instance. So yeah, whatever you're most comfortable with, but I would just say using decimals allows you to use the calculator a little more. So V, as I mentioned, if you have any questions that you want to make sure we cover, feel free to shoot those to me by email and I'll get them in the rotation here. For now, though, let's keep going on the questions that Sarah sent. Da, 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 da.
Sorry, Andrew, can I just
Yeah.
ask? It can
Mhm.
be like any topic, the questions.
Oh yeah. Yeah, yeah.
Okay.
Um, ooh, another Manhattan question. Yeah. If P is the sum of all integers from 1 to 150 inclusive, and Q is the sum of all the integers from 1 to 148 inclusive, what's the value of P minus Q? All right. I'm gonna do the kind of like tricky fun way first. If I wrote this out, I would so P is the sum of all these numbers. It's 1 plus 2 plus 3 plus 4 dot 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 plus where do I want to go here? 157 plus 158. Great, V, if possible, if you could send me like screenshots of them just so I can like quickly share them right away. Yeah. Oh, no, sorry, not 158. Only to 150. So 147, 148, and 147, 148, 149, and 150. So that's what P is. Whereas Q is the sum of integers from, is that right? It's not like all even integers or anything. I'm not missing anything. No? Okay. 1 plus 2 plus 3 dot 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 only up to 148. So 147 plus 148. And what this problem is saying is subtract. Well, Sarah, if I subtract, what's going to happen? These two sets or these two sums are identical all the way up to this point.
Right.
So those just kind of cancel out, right? And what I'm left with
Yes.
is this, which is 299 minus 0. So that should come out to 299.
Wow. So easy. So much easier than the explanation in the back of the book.
They didn't do it like
Wow.
this? Yeah, that's
No,
Manhattan for
it's
you.
very intensive. Now suddenly I really like this problem.
Yeah. Um, excellent. And oh, I think Vivian just sent one here. So let's jump over. Oh, no, 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 sorry. That was a screenshot you sent earlier, Vivian. Um, uh, let's keep going here. A, B, and C are positive even integers such that A is less, sorry, 8 is greater than A, is greater than B, is greater than C. Well, I'll just ask this, Sarah. Can you give me numbers that A, B, and C could be?
Yeah, so I guess my specific question about this one is if I wanted to test more numbers, it seems a little tricky because of the parameters
Yeah.
given in the equation.
Yep.
So I think I just set up um, I should refer back to my work, but I think it was just uh, I want to say 2, 4, and 6.
Can it be anything else? I mean, you're right. These
I
are these are very strict constraints.
Yeah, I don't think that it can, and that was my one question is there anything else it could be so that I could exhaust uh testing numbers, or is it really just one?
That's it. I mean, those are all the even numbers I can think of, or I should say positive even numbers I can think of, right?
Hmm.
Because yeah, no, that's
Okay.
it. So A, B, and C have to be 6, 4, and 2. And
Right.
then this comes down to a definition of what range is.
Right.
What's the range from 6 to 2?
4.
4, right? And for anyone watching who's not familiar, range is like the distance between the highest and the lowest. So that's a distance of 4 right there. The average of 6, 4, and 2, we can calculate that, but also it's like it's evenly distributed or evenly spaced out. So this is also
Right.
4, meaning those are even.
Right. Beautiful. Okay.
Yeah. Great. Just check to see if there are any. Nope. Okay. So Sarah, let's keep going here on this one. Oh, similar question, right? A, B, and C are consecutive integers, noting that, oh, this is a good one. Oh, this is a little tricky. I see what they're saying, what they're doing here. Um, they never said positive, even, negative, right? They're just consecutive. So let's start with a case, Sarah. What are three numbers you could give that are consecutive?
1, 2, 3.
Love it, right? Those fit the constraints of the problem nicely. So what's the range of one, two, and three?
That's gonna be 2.
Two. And what's the average of one, two, and three?
6 divided by 3, 2.
Two. Great. And just as I'm like nitpicking a little bit, just as a little hack here, what's the average of 4,000, 4,001, and 4,002 without doing any math? What's the average of those three numbers?
The middle number.
Has to be the middle number, right? If they're evenly spaced like that,
Right.
right? And so I promise I don't have a problem with you like calculating that out if it makes you feel more confident in the answer. But just as a time saving thing, if it's a list of consecutive numbers, the middle one is always the average.
Mhm.
Okay,
In
now,
this
oh yeah,
problem,
hmm,
can we can test other numbers such as like negative numbers?
sure. So to be methodical, right?
Yes.
We just found one case where they're equal. So answer option A, answer option B are out.
Right.
Well, uh, give me three new numbers that still fit the constraints of the problem,
-10, -9, -8.
right? The range of these numbers.
That is a tricky question. I don't know. The range. Would it just be uh I don't know, there's negatives and now I'm blanking.
Well, range is a distance. So what's the
Hmm.
distance between the greatest and the least?
Okay. -2 or just 2?
Just two, right? Distance is always
Okay.
expressed in positive terms. So the
Gotcha.
distance,
Yes.
right? Distance of two.
Yes. Yeah.
What's the average number of these three numbers? No calculations allowed. -10, -9, -8.
-9.
Nine. Game over, right? I have one case where they're equal, one case where
Uh-huh.
that's greater.
Yes. So D.
That's it.
Great.
Look it up. All right, let's keep going here. Ooh, that looks fun. Okay, x squared is greater than y squared, and x is greater than negative the absolute value of y. So this is making my head hurt a little bit. I'll be quite honest. Um, let's just start with a case that works, and we might have to poke around a little bit here. I'm going to draw a number line. Sarah, could you give me a value for x and a value of y that you want to try, as long as they fit this constraint?
Yes. Um, what about 3 and 2?
Let's make sure that works. So 3 squared is 9, which is greater than 4. So check on that. And 3 is greater than negative absolute value of 2. Check on that.
Mhm.
So I at least have one case where quantity A is greater, meaning which answer options can I immediately eliminate?
Um, B
Yep. And
and C.
on, right? So worst case, I've gotten myself down to a 50-50. That's not bad. Now here comes the hard part. Let's try to find a case either where they're equal, they're not going to be equal, right? So let's find a case where quantity B is greater. You might have to try negatives and fractions. Can you try to come up with a case where Y is greater than X?
Um, what if X is 4 and Y is 2? No, that's way too similar. Way too similar to what we just did. Hold on. You said to use fractions or decimals, and I'm trying to make Y greater than X.
Right, you're threading a very narrow needle here. You want to make y greater than x, and you want it to pass these two tests.
Mhm. Okay. Um, hmm, I'm feeling stuck.
It's a tough one, and I'll open it to audience suggestions here. Um, can anyone come up with a value for x and a value for y that will pass both of these tests so that y is greater than x? What about x is -1? No, that still doesn't work. um,
What about -3?
you said x is -3.
Mm-hmm.
Might pass that first test. It's not going to pass this one.
Mm-hmm.
So how about this is a real stinker of a problem. We want that to be greater than. Okay. I think I see one. What about x is like 0.5 and y is negative? Hmm,
Did we already go through that zone F? And
we,
we said that
yeah,
they're
we're kind of implicitly going through. So it's going to be somewhere around here. It's going to be somewhere around the 0, 1 negative extreme or fractions. And the issue that we have is that this could be, so this has to be greater than, x squared has to be greater than y squared. So maybe make that negative 0.6. But even then, uh, sorry, is the answer to this one A or is it D?
It is A.
It is A. Yeah. Okay. I'm not seeing another way to break this problem. And I'm looking for a better kind of like more categorical way to say it. I guess what you could say is this. Okay. So we know that x squared is greater than y squared. Another way of saying that is that the absolute value of x is greater than the absolute value of y, right? So that means either, it's like xy or xy, because when you square it, they both become positive. Yeah, there is no way for x to be less than y, because if it were, we would be down here and then it would break that one.
Right.
Yeah.
Okay.
Yeah, that's a tough one.
It is.
Little doubts about that one myself. Yeah. Um, okay. And I just saw in the chat on YouTube, Victoria Joy was asking how often I do the office hours. I do them about twice a month, más o menos. But if you want to find out more information, Victoria Joy, or ask any questions to me, I'm happy to set up a time to chat on Zoom. Feel free to visit my website, testprepstudios.com. And you can sign up for future office hours there. All right, let's keep rolling here. So we did 33. I think this is the last or second to last one. Okay. Um, sum of four consecutive integers is -2. Okay. This one you can kind of poke around in the dark. Oh, thank you, Sarah, for putting that in the chat there. This one you can kind of poke around. So let's start with this. Sarah, can you just give me a number?
4.
4. Okay. So what's the sum of the four consecutive integers starting with 4? 4 plus 5 plus 6 plus 7.
Okay. Okay, so we've got to go with a lower number then.
Much lower, right? What do you want to try now?
Yes. So like -7.
Start with -7.
Mm-hmm.
-7, -6, -5, -4. That's too low.
Mm-hmm.
Let's fine tune it a little bit.
-2.
-2, -1, 0, 1. What's the sum of these?
Um, 0.
What's -2 plus -1
-3.
plus 0
0 or -3 plus
plus
1
1?
-2. Okay.
So that's the winner, right?
Okay.
And what's the smallest of the four
Smallest.
numbers?
Oh, I see. -2. So they're equal.
So those are, yep,
And
exactly.
there's nothing else that could, there are no other numbers, 4 consecutive integers that would add to -2.
That's a great, especially for the GRE, great question to ask. Why not? I mean, it's true, but can you sort of like
Mhm.
justify that?
Not really. I would imagine that there is another way to get to -2
Mhm.
with 4 consecutive integers.
The
Well,
amount that it's increasing never changes, regardless of how big or small the number is, right?
right. Exactly. Right. So if I were to like shift over one and do -1, 0, 1, 2, now I'm getting bigger and bigger and bigger, right? Versus getting smaller and smaller and smaller and smaller. So
Right.
like if the sum is -2, I'm going to be adding or subtracting different values to the top and bottom, so it won't equal -2 again.
Right. Okay.
Yep.
So this is the only scenario then. Okay.
Great. And Vivian, I got your PDF. There's one more question on this one, so we'll just knock this one out and then we'll jump over to yours. G is an integer, X is a prime number. Which of the following must be an integer? Okay. So G squared X, G is an integer. This just comes at to breaking things up a little bit. So G squared X over X plus 5G X over X. Are you okay, Sarah, if I just break that up like this
Yes,
into two fractions,
totally.
right? And then I can cancel this out, cancel that out, and I get G squared, which is an integer, right? G is an integer. So if I square an integer, I get an integer, plus 5 times an integer, 5G,
Mhm.
that's an integer. It's an integer plus an integer is an integer.
Mhm.
So far, so good?
Yes.
Okay. Then we get into this prime number business. So we'll talk about that. Okay. So G squared, an integer squared is an integer. So that's fine, right? That's taken care of. But let's look at this business over here. X is a prime number. And I always like to start with the smallest prime number. What's the smallest prime number, Sarah?
2.
Yes. And what's 2 squared?
4.
Divided by 3?
Um, That is not a whole number.
Game over, right? This is going to be
Okay.
an integer minus possibly not an integer, but this is a must be true question. So
Yes.
that's out right then and there.
Okay, gotcha.
And then there's no x in this one, but it's 6. So it's 6 times g over 2 is the same thing as 3 times g. Are you okay if I do that?
Yes, it is totally okay.
Right. So that's an integer right there. And then if I square g over 2, this is minus 100 g squared over 4. I squared the top and the
Right.
bottom. And
Mm-hmm.
100 over 4 is 25. So it's an integer minus 25
Mm,
times an integer squared. Still an integer. Doesn't have to be a
right.
positive integer, but it is still an integer. So that one is in.
Got it. Okay.
And that's what I get for these two.
Perfect. All righty, sweet. Thank you so
Yeah, of
much.
course. Okay, Vivian, let's hop over to yours. I'm gonna download this here. So this was for anyone following along. Vivian, this is in the official guide, right? Not the practice book. Oh no, it is in the practice book, the verbal reasoning
Yes.
practice book.
Yep.
Okay, got it. Oh shoot, where did I put that? 1 second. Uh, and this was set 6. So I'll share my screen here and then anyone can follow along at home. Do I have set 6? Oh no, this is in the official guide, isn't it? The bigger book. Reading comprehension. So let me pull this up. Yeah, farmland or whatever it is. This is almost a math question. I like this one. Okay. Um, oh, good. It's mushed into one. Gotcha. All right. So, Vivian, was it just the first set or like all of the questions or any particular one that you wanted to start with?
Uh, I fear it was the whole set. Set 6 was just
Yeah.
it's just terrible for me.
Yeah, let's take a look at this one here. Um, so again, with this particular one is almost a math question. If it's the one that I remember, I just need to reread this for myself. The United States being, oh, wait. All right, lower than that of the general population, which directly contradicts. The number of farmers continued to increase, but at a rate lower than the general population. Yeah. So I'll hide these thumbnails so that we have a
So
little.
I guess I wanted to start out, but just even being able to eliminate some things.
Mhm.
But again, like even the answers I came up to, I either was forgetting some or just I was completely off.
Mhm.
And I'm just wondering if there's like a way for me to almost guarantee to get at least half of these questions right on this set.
Fair enough. Um, so in the United States between 1850 and 1880, the number of farmers continued to increase, but at a rate lower than that of the general population. So I don't know how many farmers there are in the population. Let's, for the sake of argument, and again, this is more of a math problem. I don't know what it's doing in the reading section, but it has to do with rate, which we were talking about today. Let's say there are 100 farmers out of 200 total people, farmers and non-farmers. It's saying that this number is going up, but not as fast as this number. So as a share of the population, are farmers becoming a larger share of the population or a smaller share of the population?
Smaller.
And we want something that contradicts the statement. And answer option E, which I think is the correct answer, we can double check that in a second, contradicts it. It says the proportion of farmers is getting bigger.
Can we go through all the
Yeah.
all the
So for the first one here, all it told us was that the number of farmers increased. I don't know if they increased slightly or dramatically or whatever. So are you okay getting rid of A?
yes.
The rate of growth of the US labor force and the rate of growth of the general population rose simultaneously in the 30 years. Doesn't tell me anything about the labor force. Right? The only two sort of like pools that I have are the farmers and the general population. That's it.
Yep.
D's out, right? The proportion of farmers in the labor force remained constant. Well, that's did you say C for this one?
I did.
I see. Okay. And I see why. I see the proportion of farmers in the United States remained constant between years.
And I think you kind of the reason why I did say that was because it's contradicting, because if you're saying it's going to be relative to the population, it would not
Wouldn't stay the
it
same.
would not remain constant.
Oh, you know what though? There's the issue. It's not in the general population, it's in the labor force. Whereas E talks about the proportion in the general population.
Okay.
Does that make sense, V?
It does.
It's sneaky, right? Like they love to do that, but that's fair game. And I clearly missed it on my first read too. The proportion of farmers, and again, I would say any time they bring up the labor force here, we don't have any information about the labor force. We're talking about the general population. So it has to be. And then this next one, I think, is very similarly about sort of like shares, more of a math problem. Let me get your first sort of take on this, B.
Well, just tell you what I picked as the answer.
Yeah. How did you approach this, and why did you pick what you picked?
So I picked D initially.
You say a B or D?
D, dog.
Got it.
Honestly, I just didn't. It got to a point where it just started getting confusing, and I was just going to pick one, and I just didn't know what I need to be paying attention to as far as the question goes.
Yeah.
To be able to answer it correctly.
Yeah, I'm going to quibble with this question. I don't do this very often, but when I feel it's a little unfair, I will say you kind of have an advantage here if you like grew up on a farm. Because V, are you familiar with the definition of this word fallow?
No.
You kind of need it to solve this problem. So fallow means unused. If like, and it's particularly talking about farmland. If farmland is lying fallow, it means that it's unused. Now, actually, yeah, I'm going back and forth here. They give us a definition. They say total agricultural acreage. So all acreage is the sum of planted acreage plus fallow acreage. Now I know it's a little bit of a stretch, but you might define fallow as non-planted acreage, right? If total acreage is planted plus fallow, you could also just say planted plus non-planted. So fallow is non-planted acreage. Let's start there. So this says that when you only compare planted acreage, the Soviet yield is less than the US yield, right? So when we're only looking at land that has things planted on it, the US sort of wins that competition. But when you look at all land, right, used and unused, the positions flip. Now, by definition, in this problem, there are only two types of acreage that we're considering: planted and fallow, or planted and non-planted. So if this yield flips, right, it must be the case that the US has more fallow acreage than the Soviet Union. Sorry, a higher proportion or a higher percentage of it. And I'll break that down a little more minutely in a second, but I'll pause right there and ask you any questions what I've said so far.
Honestly, I don't even think I followed.
Okay. Yeah.
So I guess there's nothing about the wording other than just being able to know if this is less than, this is greater. There's nothing I can like be able to eliminate straight off before, like, you know how we were talking in class about if you see inferred, you should just kind of go through the multiple choice and just at least be able to get rid of half of them.
Well, so that was for, I think that was talking about big picture questions and the verbs. So this is definitely not one of those. The way to get rid of inferred answers, and you can't really do it on this one because this one is a little more mathematical. But the way to get rid of inferred answers would be if there's anything very categorical, like all, none, every, nothing, ever. And I don't see any of that language here. So
Yeah.
this one is more of a, again, like a math question.
Okay.
And so I'll take a stab at the logic of it again, and I'll try to put some numbers on it. So, and I'll try to like tell it in the terms of a story. Pretend that, a representative of the United States and a representative of the Soviet Union meet at a conference, and they're arguing about like which system is better. And the person in the United States says, look at all of the farmland that we use for farming, right? If you compare the plots of land that are growing things, our plants grow faster. Our plants grow bigger and better. And then the person from the Soviet Union says, yes. But if you compare all of what you produce and all of the land that you have, we produce more. Because the first comparison is basically saying we only look at fallow land. And then in the second comparison, the person in the Soviet Union says, yeah, but you leave a lot of land lying fallow. Like that's kind of cheating.
Okay.
Does that make sense?
Yeah, the denominator is what they're by this. Okay,
Right.
I completely missed that.
I know it's again more of a math question here. And denominator is, I think, a much better way to kind of get at what I'm trying to turn this into a big story. But that's the change. That when we consider all land, the Soviet farms have a higher yield, or the Soviet Union has a higher yield.
So basically, if anything, they're just saying of all the land that the Soviet Union has, they're taking advantage of way more than the United States are. As far as
Yes.
okay.
Basically, like what could the only thing in this sort of closed universe that could account for this switch was the fact that a higher percentage was that the US wasn't using all the land.
Wait, but isn't that the same as D? Because the Soviet Union also has more planted acreage.
We're talking about shares, though.
Oh,
I don't know about the actual number.
I see. Yeah.
Yeah. And V, just to kind of like fit this into the models that we're talking about, remember this isn't a technically a critical reasoning question. It is a reading question. But when we do critical reasoning in a couple of weeks, we will look at some more mathy reading question types.
Okay.
So we're not done talking about reading yet. But yeah, these are tough. All right, let's do one more here. Is this the one you want to do, V? Or is there a different one?
Yeah. So either I guess either 3, 4, or 5.
Okay. Yeah, let's take a look at this. All right. So we're dealing with an inference question. It can be inferred that the process described in the passage makes use of which of the following? What did you say for this one?
Initially, I had said just B.
Just B. And I think that's the correct answer. Did the book say it was different?
B and C.
Really? For number 3?
Yeah.
Okay, yeah. Got it. Yep. I was thinking of a different question here. Can be further process describes makes use of which of the following? So you're sold on B. You buy this one, right?
Yes.
Let's talk about this other one, and let me actually reread this passage very quickly because it's been a while for me. For hot desert location. Hmm. Can be inferred that the process described makes use of which of the following. So it definitely does not talk about the tendency of hot air to rise. We can't infer that or assume that. The temperature differential between the sea and the desert. So if it's talking about the desert here, and by definition, hot, I know I'm being very like mechanical, but hot means high temperature. Oriented by the prevailing wind, the front wall is perforated cover, moistened and cooled by a trickle of seawater. There it is. Cool, humidified air.
I guess my main question here for the C one is because when we were talking before, we said we didn't want to make assumptions,
Right.
right? So it could seem obvious, but we don't want to imply anything. I don't know that it was completely clear that option C was a right answer. I could have come to that conclusion, but I don't see it directly in the passage.
Well, let's go to the definition of words, and we'll get into this when we talk about vocab too. Is hot different from cool?
Yes.
That's a differential,
Okay.
right? And so like even though it doesn't explicitly say that it doesn't say the words like the temperatures are different, it says one is hot and one is cool. And that by definition means that there is a differential.
Okay.
And I'll add like that. We don't even need to go that far, right? Just the definitions of the words hot and cool is what kind of gets us that. Okay, great. So I got to run now. I will have more office hours, I promise. Probably not next week, very likely the week after that. I'll keep everybody posted. Again, keep an eye on my website when I post them in the office hours section. And feel free to send me any questions that you have. And I'll talk to everyone later. We'll stop streaming now. Did it stop streaming already? No, it says it's streaming right now. Stop sharing.